Welcome to Python Aliases! Have you ever had to type a really long module name over and over again in your Python code? It gets tedious fast. That's exactly the problem aliases solve. In this tutorial, you'll learn what an alias is in Python, how to create one using the alias keyword, when and why you'd actually use aliases, and real-world examples you'll see in almost every Python project. No prior experience with aliases needed. If you know how to import a module, you're ready to go. What is an alias? Think of an alias like a nickname. Your friend's name might be Alexander, but you just call him Alex. It's the same person, just easier to say. In Python, an alias is a shorter or simpler name you give to a module when you import it. Instead of typing the full module name every single time you use it, you use the nickname instead. Watch as we show the analogy. Alexander becomes Alex, just like matplotlib becomes pleat. Same thing, much easier to work with. Creating an alias in Python is done using the as keyword right at the point of import. The syntax is simple. Import module name as alias. Let's break down what each part does. The import keyword tells Python you want to bring in an external module. Module name is the actual name of the module you're importing. The as keyword signals that you're about to assign a nickname, and alias is the nickname you want to use throughout your code. That's it. Once you've created an alias, you can use that shorter name anywhere in your code instead of the full module name. Why do developers use aliases? There are two main reasons. First, to save typing time. Some popular Python libraries have long names. Typing them out every single time you use them makes your code messy and slow to write. Aliases make your code cleaner and faster to write. Second, to avoid naming conflicts. Sometimes, two different modules have functions or classes with the exact same name. Aliases let you keep both without one overwriting the other. This keeps your code clear and prevents confusing bugs. Let's look at one of the most common examples in data science. matplotlib.pyplot. Imagine typing that every single time you want to draw a chart. Without an alias, you'd write matplotlib.pyplot. That's a lot of typing. Now compare that to using an alias. You import matplotlib, and then you can just write plt.plot and plt.show. Same result, far less typing. The alias plt is just a convention the Python community agrees on. You could technically use any name, but sticking to plt makes your code instantly recognizable to other developers. Two of the most widely used Python libraries, pandas and numpy, are almost always imported with aliases. You'll see import numpy as np and import pandas as pd in almost every data science project. Here's them in action. Using numpy to create an array, you write np because numpy array with your values. Using pandas to create a data frame, you write pd frame with your data dictionary. Watch the output. We get our array of numbers and our table with names and scores. Without aliases, you'd have to write numpy, array, and pandas data frame every single time. Aliases make the code far more readable and much faster to write. Now, let's see how aliases prevent naming conflicts. Imagine you have two custom modules, both containing a function called calculate. If you import them normally using from module stop import calculate and from module stop d import calculate, the second import overwrites the first. Python won't know which one you mean. Aliases come to the rescue. Instead, you write import module stop as a and import module stop d as b. Now you can call a stop calculate to get the result from module stop. Watch the output. We get results from both modules clearly. There's zero ambiguity. Each call is perfectly clear about which module it's using. If you've started using Python's type hints, you might have run into hints that look a bit overwhelming. A function signature like def process, sugars, With data typed as dict of string to list of int is hard to read. You can use a type alias to clean this up. First, import dict and list from the typing module. Then give the complex type a clear, descriptive name like score data equals dict of string to list of int. Now your function signature just uses score data, which is much easier to read, and clearly communicates what kind of data the function expects. The function works exactly the same, but the code is far more readable. The Python community has settled on standard aliases for the most popular libraries. Using these makes your code immediately understandable to any other Python developer. Here are the conventions you should know. Numpy is always NP, pandas is always PD, matplotlib.pyplot always pre-plo, Seaborn is SNS, and TensorFlow is TF. Stick to these conventions unless you have a very good reason not to. Consistency matters in collaborative coding. When you use non-standard aliases, other developers have to pause and figure out what you're doing. Using the standard aliases shows you know the community norms and makes your code professional. Let's recap everything you learned in this tutorial. An alias is a nickname for a module assigned using the as keyword. The syntax is import module name as alias. Use aliases to shorten long module names and save typing time. Use aliases to avoid naming conflicts when two modules have functions with the same name. You can also use type aliases to make complex type hints cleaner and more readable. And most importantly, stick to community conventions like NP for NumPy, PD for pandas, and PLT for matplotlib.pyplot. These conventions make your code instantly recognizable and professional. Congratulations! You've now mastered Python aliases. You know what they are, how to create them, and when to use them. Try importing NumPy as NP and creating an array. Import pandas as PD and create a data frame. And remember to always use the community standard aliases in your code. Thanks for watching, and don't forget to like and subscribe for more Python tutorials. Happy coding!